anytime I have a question that involves a physical object, like the silo in this one, I always like to start by drawing a picture. So first, I know I have a cylinder. So a cylinder has two circular bases. Looks like this. And the diameter is 80 feet. And the height is 200 feet. And it's capped with a hemisphere. So there's a hemispherical dome here on top. All right, and I need to figure out two things. I want to know what's its volume, or how much stuff can the owner store in it, and I want to know what the surface area is. So if you want to paint it, that's a number you're going to need to have to figure out how many gallons of paint to get. Okay, so to find the volume, I'm going to have to split this into two parts. First, I'll find the volume of the cylinder. Then I'll find the volume of the hemisphere. We'll add those together, and we'll get the total volume. So the volume of a cylinder, that's pi r squared h. And the volume of a sphere is 4/3 pi r cubed, but we only have a hemisphere. It's half of that. All right, so let's put some numbers in. This is pi times the radius. Now I have the diameter. Remember, the radius is half that, so that'll be 40 squared times 200 plus 1/2 times 4/3. That's 2/3 pi times 40 cubed. And now we're coming to the point where you probably want to get your calculator out. This is 320,000 pi plus 42,666.67 pi. And we could add those two together, but it's a practical question. So at the end, I want my answer to be a decimal. I'll usually hold on to that pi for a while because to me, it's easier to work with it rather than making the decimals even messier by putting 3.14 in there. But this is the point where I would go ahead and substitute 3.14 for pi. And if you do that, you end up with 113,877.33. So that's what? About 1.10 million. And what are our units here? We're measuring in feet, right? So it's cubic feet. So to find the surface area, I'm really going to have to do the same thing. I'm going to have to split this into two parts. First, there's not volume anymore. We're doing the area. So A equals the area of the cylinder, and that's just the lateral area, right? Because we don't have to paint the bottom. We don't have to paint the ground down here, and that part right there is just open air. So it's just going to be the lateral area. And we'll add to that the area of the hemisphere. So the lateral area of a cylinder, that is 2 pi r h. And the area of a hemisphere, of a circle, is 4 pi r squared. But again, we just have half of one. All right, so we put our numbers in. This is 2 pi times 40 times 200. Plus 1/2 times 4, that's 2, times pi times 40 squared. And if we do some arithmetic here, this is 16,000 pi plus, that's 3,200 pi. Again, this is the point where I get out my calculator. This is about 60,288 square feet. So this question is a little trickier because it really is going to force us to draw a three-dimensional diagram if we want to get a picture of what's happening here. So the problem says we have two 20-inch spheres. Since it didn't give any more specific information, if it just says a 20-inch sphere, that means the sphere's diameter, not the radius. So we've got one there, well, that's not too bad, and one there, and they're each 20 inches across. And we need to put them in a box. And they're going to fit snugly into this box. So they're going to be packed right up against the edges. This is where it's going to get a little tricky to draw. My box is going to go here, then back behind them, then over here, and down in front, something like this. give or take my very limited artistic skills. Okay, so we have two questions then. We need to know how much material will be required to make the box. Well, what does that mean? We're talking about flat surfaces, right? The panels that make up the six sides. So when the question is how much material will be required to make a box, that means the surface area, right? How much area is going to be required. So we have, let me fill in the top line there, I left that out. We have a rectangular solid, and it's got six pieces, right? There's the two side pieces. Let me put this one in here. This is going to be 20 inches because that's the distance across one of the spheres. And the height here is also going to be 20 inches because that's also the distance across a single sphere. So my surface area is going to be 2 times 20 times 20. That's the left and right hand pieces. The top and bottom are 2 times 20 times 40. And the front and back, those are also 20 times 40. This will be a second 2 times 20 times 40. And then you get your calculator out, right? You do the arithmetic here. This is 20 times 20 is 400, times 2 is 800, plus this is 800 times 2, that's 1600, plus another 1600. You add those together, you get a total of 4,000 square inches for the surface area of the box. Now, the second question here says if the empty space around the spheres has to be filled with a packing foam, how much will we need? So I'm looking for the volume inside the box, but outside the two spheres. Right, so what I'm going to do here is the volume I'm looking for is going to be the volume of the box minus the volume of the spheres. Okay, so the volume of a box, that's length times width times height. So this is 20 times 20 times 40 minus the volume of the spheres. Well, the volume of one of the spheres is 4/3 pi r cubed. Now the radius here, right, we're always being careful with diameter versus radius. The diameter here is just going to be 10 inches. So that'll be 4/3 pi times 10 cubed. And I'm going to double that because we have two of them. Okay, so what does this come out to then? This is 16,000 minus 8,373.3 is what my calculator tells me. And if we do the subtraction here, the space in between the box and the spheres is going to be 7,626.7 cubic inches. Okay, so those are two kind of classic examples for ways we can use the formulas we've been talking about for volume and surface area. So I do have a couple more than we want to talk about, right? And that's what we'll look at in the next lecture.